So once we know the slope of the tangent line, then we're going to be asked to find the equation of the tangent line. We use the tangent line to approximate the actual curve. So you use the tangent line and say, well, if you look right here, they're really not very far apart, and the line is usually much easier to use for an approximation than the actual curve itself. So for these same three examples, let's find the equation of the tangent line. And first we're going to do a little review of equations of lines. So we've already talked about slope. We know the formula, the second y minus the first y divided by the second x minus the first x. And recall that if you have a vertical line, then the slope is undefined. We don't really see those very much in business calculus. So quick reminder, slope of the line between these 2 points is going to be -1 minus -2, second y minus the first y, over the second x minus the first x. So we're going to get 1/3, or 1/3. And recall that the slope of a horizontal line, you have the letter z here to be your cue and remind you that the slope of a horizontal line is 0. So most of us are the most familiar with slope-intercept form of the equation of a line, and that's helpful if you're drawing the graph, but we're not going to be drawing graphs, so that's actually not going to be the most useful form for us. Quick reminder about what different lines with different numbers for slopes look like. So this line A has the smallest slope of this group. It's 1/2 up 1/2. So it's not very steep. It's increasing, but not very quickly. Then when the slope is 1, that's actually pretty steep. And then a slope of 3 even steeper and 7 even steeper. And then if the lines go downhill from left to right, line E has a slope of -1/2, so it's going downhill, but not very steeply. Then we have a slope of -1, steeper downhill, -3, -7. So I just want you to have those pictures in your mind. Quick review of parallel and perpendicular lines. Lines with the same slope are parallel. Lines with a slope that are the negative reciprocal of each other, those are perpendicular lines. So here are two lines, and we're supposed to decide if they're parallel, perpendicular, or neither. So we're going to solve for y, because that's the easiest way to figure out what the slope is. So we're going to have -5y equals -2x plus 7, and divide both sides by -5. So line 1 can be written as y equals 2/5 x minus 7/5. So we have a slope of 2/5. So then for line 2, we're going to add 5 to both sides, get 15y equals 6x plus 5, then divide both sides by 15, and get line 2 is y equals, let's see, 6/15 is going to reduce to 2/5 x plus 1/3. So the slopes are the same, so these lines are parallel. And then I'll let you do the second example because I'm betting you can. So the point slope form is actually the most useful for us in calculus because as you just saw, we were getting slopes when we were doing the calculus work of finding the instantaneous rate of change. So if we know the slope of the line, and we'll know the slope from our tangent line slope calculation, and a point on the line, then we will be using this form of the equation of a line, and it's called the point slope equation. So here's find the equation of the line through these 2 points, and we already found that the slope was -1 minus -2 over 2 minus -1, or 1/3. So that's our slope. Then we can use either one of the 2 points. So let's use the second point because it doesn't have both numbers negative. So we'll have y minus -1, the y coordinate of the point I know, equals 1/3 the slope, x minus the x coordinate of the point I know. So this is called the point slope form. You can easily switch it to the slope-intercept form if you like it better that way. And you'd get y equals 1/3 x minus 5/3. But this form of the equation of a line is an equation of a line. And so if that's what you're asked for, you're done when you get to that point. So let's look back at these lines that we found slopes for. So for A here, we had, let's see, it was -4 times -1, or 4 was our slope. Well, now we know x equals -1, but we need a y coordinate. So recall that we can find that by doing g of -1. So -1 comma -1 is the point we know is on our graph. So we're going to have y minus -1 equals 4 times x minus -1, which we should write as y plus 1 equals 4 times x plus 1, and then you're done. If you want to compare with answers in the back of the book, you're going to have to rewrite it in slope-intercept form, but it's just a quick algebra calculation. And there we have the slope of the equation, the equation of the tangent line when x equals -1. So this first calculation we did gave us the slope. Then we're given an x coordinate, and we can use the function to find a y coordinate. And then we use the point slope form of the equation of a line. So I do have one example with interpreting this, what we've been doing. So they're called derivatives when we find these instantaneous rates of change. And here's an example where we have a linear relationship, and we're going to practice writing the linear equation. So I'm going to organize my information because I just like to do that. So we're going to have year and production. So I can see in 2005, my production was 3.3 million metric tons. And in 2015, it was 4.1 million metric tons. So they're telling us how to use our variables. They're saying the production is y, so this is my y variable. And x is the number of years after 2000. So this column is not going to be x. I need another column for x, and it's going to be 5 and 15, just so I can work with smaller numbers. So I have the 2 points, 5, 3.3, and 15, 4.1. So I can find my slope, second y minus the first y, over the second x minus the first x. That looks like 0.8 divided by 10, so that's going to be 0.08. And this is going to be in million metric tons per year. So that's just the slope part, but now we need a line equation. So we're going to have, I'm going to use the first point, y minus 3.3 equals 0.08 times x minus 5. So we'll have y equals 0.08x minus 4 plus 3.3. So it looks like y equals 0.08x minus 0.7. So that's our linear equation, the equation of a line that relates those two quantities, years and production. So then it says, what is the cocoa bean production in 2012? So we're going to say f of 12 equals 0.08 times 12 minus 0.7. So let's get our calculators out and get 0.26. And that doesn't look right, so let me do a quick check. So this was a 0.4 back here. So this needs to be plus 2.9. So let's see what we get now. And I'm getting 3.86, and that seems reasonable since it's a year between these two, and it's a quantity between those two quantities. So make sure you add million metric tons. And then C says, if the trend continues, what will be the first full year in which cocoa bean production exceeds 5 million metric tons? So you want to know, when is f of x going to be bigger than 5? So you want to know, when is 0.08x plus 2.9 going to be bigger than 5? So we solve this inequality. And we're going to have 2.1 on the right and 0.08x. So divide both sides by positive 0.08, so we don't have to do anything about changing the direction of the inequality. And this says x is bigger than 26.25. So it says the first full year, so that would be when x is 27, and so that would be the year 2027, since x is years after 2000. So it will take a while to get over 5 million metric tons.